The seismic testing we're doing out here today is to prove the performance of helical piles in liquefaction. And what happens in liquefaction is there's water in the soil, and when it shakes, it turns into almost a jello or pudding. So any structure on top of that would be like a boat, a sinking boat in that element.
This is the first testing that's ever been done in the U.S. for liquefaction testing on remedial repair piles. So this test is to show how helical piles will perform supporting existing structures.
We obviously stand behind our product and are confident in our product, but getting the different building jurisdictions and engineering society to understand what we do and why we do it and the benefits of helical piles, this could be huge.
This test could help with defining how the helical piles are going to react in seismic zones and liquefaction zones. Are they going to behave like a column, or are they going to have some type of lateral support through that? But the consensus has always been that when you have a liquefaction zone, it's a fluid soil. So it's providing no lateral capacity to the deep foundation element.
We've been studying liquefaction at the University of Nevada, Reno for past several years. So this research is funded by the Pacific Earthquake Engineering Research Center, or PEER, which is headquartered at the University of California, Berkeley. PEER mission is to support and disseminate research related to performance-based earthquake engineering. And this test is a great example in which we've tried to improve the performance of foundation systems using helical piles. So this is the second test we've done here. The first test, which was done back in June last year, there was a foundation system with no mitigation measures. During that test, we observed over 11 inches of settlement in the foundation system, whereas this test today, we were able to implement helical piles to reduce the foundation settlements, and what we've seen has been less than half-inch settlement. So it's been great improvement to the foundation system.
Yeah, on the original testing that we did, they had their block weight and without any underpinning at all underneath of it. And it settled 11 inches when it went through the seismic events. We had the exact same loads, the exact same setup with the liquefaction, except that we had our piles underneath of it. We had 4 piles supporting that footing. And with that same shake, it only moved a half of an inch, which is substantial. I mean, 11 inches on a structure is going to collapse, most likely. But a half inch, people are going to survive.
As the building codes get stricter, there's going to be requirements for upgraded seismic on homes and buildings. And with helical piles, we can mitigate a lot of the cost that is incurred by these seismic upgrades by having the least invasive solution. And with these tests, that will give us the ability to prove to the engineering society and the building officials that helical piles are the best solution in many cases for seismic upgrades.
I would like to thank Ramjack again for their support to do this project. Without Ramjack's support, we weren't able to do this kind of testing. Ramjack's helical piles, they perform very well. We are very happy, satisfied with the results.